Okay, now let's talk about how we calculate a correlational coefficient. There are several formulas you could use. The one that's been around for the longest time is called the Pearson product moment correlation. This was first invented in the 1800s by Sir Francis Galton, who was a cousin of Charles Darwin. Then a guy named Pearson took it up. He was one of his students and formulated the formula. Here it is right here. I know it looks big and scary and all, but it is kind of simple. You guys just got to take it one step at a time. So we'll start with a problem like this, our depression self-esteem problem, where you have x values and you have y values. And we look at our formula. The first thing it asks for in the numerator is what's the n. N in this formula is number of pairs. So you just count the number of pairs. 1, 2, 3, 4, 5, 6, 7, 8 pairs. So wherever you see an n, you're going to substitute an 8. Let's jump over this for a second. Let's go right to this, sum of x. Well, we've already done sum of x before. We did this to calculate the mean. So you just add the x values. Sum of y, you guessed it. So add the y values. Here's something we have to do, but we did it in standard deviation. The sum of the x squareds. Well, we have to make a column of x's and square them. So we'd have a sum of x column, an x squared column, and we'd sum them. And then we do the same thing for the y's. We make a y squared column and we sum them up. Last thing we got to do is this thing called x times y, the sum of x times y. This is kind of new. In this, we just make a column and we take the x's, multiply them by the y, get a value, and sum them up. Now we have all our values to solve the problems. We have the sum of x, sum of y, sum of x squared, sum of y squared, sum of xy, and we have our n. Now it's time to solve the problem. Just be careful. Make sure you plug all the numbers in carefully. Make sure you have all the multiplication and subtraction signs properly. Make sure you have all the squares. This is how students make mistakes all the time. Make sure you transpose this formula properly, plug the numbers in, do the proper order of operations, and indeed for this problem we would find an r value. That's our Pearson product moment correlation of -0.9244.